Okay, welcome, full screen. Welcome everybody to Meetup 13 of Data 608. In this meetup, we're going to talk about making interactive visualizations, like interactive visualization apps. So this is kind of like our version of a course in our version of making dashboards using R and Python. So in a way you could think about it, there's not going to be like any principles of good visual design in this particular lecture. I'm going to try to get some of that um, maybe next week. But this is going to be more about like a useful and a powerful technology. So just for a summary, we're like getting towards the end. So we're going to have 2 weeks on learning how to make shiny apps, like principles of like the design of interactive visualizations. And then after that, like there'll be like one wrap up meetup um at the end. So you have a data story 7 um that's due, yeah, the 11th of May. And it's going to be to create a shiny app using one of your previous data stories, using one of the data sets that you worked with before. I have the description up on Brightspace. Like, so you could in theory like create a shiny app that like is just a graph or something. So please, so the assignment is not to like just create like a minimal shiny app. You should make it have some features. You should make it, actually the best is if you could make it like tell the story you told in your data story, but then like add a little interactive part too that makes it deeper. Like that would be the ideal optimal assignment. Okay. And then I'd like to advertise the meetups. I think I advertised it last week, and I'll probably advertise it next week. But Wednesday, May 7th, if you're free, if you're in the city, if you want to get some networking, you want to like listen to some statistics and machine learning, there's going to be a meetup. Send me a message if you're planning to go, and you have to buy tickets. It costs $7, but you'll get unlimited pizza. Um, if it's your thing, could definitely be well worth it. Okay, so what is Shiny? So Shiny's basically an R package which makes it easy to create an interactive web server that um that like shows the results of R and Python code. Um, and when I say easy, I mean you don't need to know anything about programming on the web. You don't need to know any Java. You don't need to know like any of that stuff. Shiny handles that for you. So if you're like very knowledgeable in R and Python, or either of those languages, um, you can get like a Shiny app running in minutes and showing your results to the world. Um, and then so it's easy to it's so so one good aspect of it is it's like pretty minimal like time investment to get set up using it, but at the same time it's also extremely powerful. Like anything you can do in R and Python you can put into a Shiny app pretty much. So like very sophisticated model, um like many complex choices for the user to make, customizing the displays, you can do all of that. And also the underlying design principles, like pretty much all aspects of the tidyverse are very well thought out, and very clean. So as you get further into Shiny, you don't find that the ship is like, glued together with band-aids. You find it's it's actually worth the effort to go deeper. um
Professor,
yep.
can you quickly go back to the page before? I just want to take a picture real quick.
Yeah, sure.
Thank you. Okay, appreciate it.
No problem. Yeah, so yeah, and then another nice another sorry, I just like had a minor panic attack, but no, I didn't. But I just thought like the previous class recording I made was 19 minutes, but it was not. So, sorry for the pause. Um, yeah, so Shiny, um, so I think many of you have experience using other dashboard, like other, tools for interactive visualizations. I think like, and I'm not sure how exactly like similar Shiny is to something like Tableau or Power BI. But it creates a similar type of product, which is like an online dashboard where you can look at stuff and maybe play with it a little bit. Um, and then like the advantages or disadvantages just depend on um what you need to do. And the advantage of this is that you write it in code so that it's easy to share with other people, easy to modify, and you can and it's like infinitely powerful. Like you can write like anything you can, do in R or Python, you can put into a Shiny app. So what does it look like in practice? So here is so you can actually put Shiny apps inside these markdown files. So here is an example of a miniature Shiny app built into the slide. And I have the Old Faithful geyser, which is a geyser in Yellowstone National Park. And it erupts frequently, but the kind of every hour, but it's not like perfectly predictable. And so this is just a histogram of like how often of the different intervals between eruptions. And you can see I have this interactive slider here, and I can just like scroll it around, and the plot automatically changes. So this is one example of like a really simple Shiny app. Here's another like slightly more complicated example. So I have the iris data set, which is I believe a data set of a bunch of different flowers. And the Shiny app here is performing k-means clustering on the different characteristics of the flowers. And I can choose the number of clusters that I want. So I can increase to 4 clusters, I can increase to 5 clusters, and it just instantly changes. Increase to 6, 7. I think I can go up to 9. Let's see. Yeah, I can't push it too far. And then I can change how I'm visualizing the clusters just on the fly. So I could look at the petals instead and get a different picture. Here we can see petal length and petal width are super correlated, and you can see how the data is shaped. And this is as you're gathering like um a lot like you could, depending on the context in which you're showing data, you could make like a separate plot for like every single different combination of these variables, and you would have like a 100-page PDF. Or you could make a Shiny app that lets the user pick and choose, and it's could be quite powerful for that reason. Let me go to the next. And then so those are two really simple examples, but the examples can be a lot more sophisticated. And I think that yes, I see hand raised. Sorry
Yeah,
if I
it's Darwin version.
yeah, no worries.
So I was just wondering, in that specific example, because you're doing K-means clustering, does R cache like all those? Because essentially, you would have had to run K-means up to 9 clusters, right? You would have had to specify K that many times. So do you? So does in R you have to run the model that many times, and then it caches that information, and it can display it on the app later on.
So the way this works is that um and we'll get into a little bit how it works later, but when I make a change here, um are like in the background, like for every single thing on this web page, there's like that's being displayed, there's like some data object, um and R has stored a graph of how those data objects depend on the inputs. And so basically when I make a change, so if I, let's say, change the cluster count to 4, it triggers R to find all of the outputs that depend on the cluster count, and it recomputes all of those. Um, so that's the default behavior. So basically, it's not caching like for all the different cluster values. It's basically just it's computing when you tell it to. I believe there is a possibility if you're doing extremely heavy computations to cache some of the results. Um, but it's not the default behavior, if that makes sense.
Oh, awesome, cool. Thank you.
Yeah. So anyway, so what is this good for? In my experience, like you know, I feel like the name kind of describes what it is pretty well. Like it's you do some really interesting like data analysis. You can create this like shiny thing on the internet that anyone can interact with, and that can like really empower you like a bit because you could create like some you could create something that's like really useful that the public can can access that if you, that like people in your organization can make use of if you're trying to convince a bunch of people to do something like oftentimes the Shiny app is helpful for communicating what your data analysis means to them. And I think uh, this is particularly good if you're trying to build a portfolio of like things you're proud of. Like, if you created like an amazing Shiny app, like that's I think that's like better like to put on your resume than let's say like putting a link to your GitHub. Yeah, that's important. Let's say, but if you have a Shiny app that's like really awesome, someone's likely to check it out um, and be impressed by it. So a case study example of this, and I'm a little bit upset with my colleague because he hasn't actually shared the code with me because I wanted to show it off. But um, which is annoying, even though he said he would. But uh, I have a colleague who works in marine conservation science. So he's an ecological modeler. He was working at forget which university. He was working at a university in Norway, and then he moved to New Zealand. And one of the things he studies is marine protected areas, which are basically like a part of the ocean where, a bunch of countries agree that there's some restrictions on fishing in order to protect like the ecosystem that's there, in order to like ensure the health of like ecosystems in the surrounding area. Um, and so it could be hard to design like a marine protected area, right? Because there's going to be like all kinds of impacts on the ecosystem, on the people who are fishing, like on the countries in which those fishing fleets are like domiciled, like, and there's going to be a lot of stakeholders, that are involved in who are going to be affected by determining the boundaries of these marine protected areas, and they're going to be like in theory having to trust the advice of the supposed experts, right? The scientists who know like how the ecosystem works. And sure, the so my colleague builds mathematical models, like he builds ecological models which say what happens, what would happen in the ecosystem if you have certain configuration of marine protected areas with like certain configuration of restrictions. However, like having that complicated object wasn't very helpful in coming to agreement between all of the stakeholders because it was like a black box that they could only really see what he would show them from the model, and they didn't really trust it. And that was until he built a Shiny app for it. And so he actually built a Shiny app which implemented his model of the marine protected zones. And for him, that was like a breakthrough in the negotiations. Like once people had access to the Shiny app and they could actually play with it and like do experiments and see what certain choices would imply and like what the predicted outcomes would be for them, then it made them a lot more comfortable with the idea. Uh, and I think that as data scientists, we're going to be working like a lot of the time with complicated models that like it would take, you know, uh, a long time to explain to someone who really is going to rely on the output of the model. And we're not going to like make them sit through like a 4-year course or 2-year course in data science just so that they can use our model. Um, but being able to kind of play with the model interactively is a way for people to learn about what the model does without having to go through like the years of education to get like all of the baseline knowledge. So in a way, it's like I think it's like a really great tool for specifically for communicating models to the general public to anyone. And I'll show like one example of like a more sophisticated model, which is pretty cool. Um, since my friend didn't share his model, or didn't share his Shiny app. This just so you can see you can do like some nice stuff with it. Let me just reload. So here's like a model developed by the New Zealand government, and I imagine this is being used by their politicians to understand like potential um impacts of policies to different groups of people in New Zealand. And so you can see here, this is a pretty snazzy looking website. Um, we see in the center a graph, and it says this graph is the typical weekly expenditure of, this is how you say, I think, person who is retired in in the New Zealand government parlance. I think this is it's called superannuation. But you can like, there's like all these different groups. So you could see you know, what the highest expenditure group spends their money on. Interesting. And you can like normalize it in different ways, etc. And the idea here is, and there's other, the idea here is to see like what would be the impact on each group based on their spendings for different types of inflation. And so um, I can like click and I can show how inflation will impact the weekly expenditure of uh, of like all the different groups. But then I can make it a comparison. I can like, see, can throw in like Maori middle income, and we can see like there's somewhat different experiences of inflation for these different groups. There's a variety of not sure if I can I'm not sure if I can control the baskets, but anyways, that's this is pretty nice. So like it just basically is like endlessly customizable. I can like even download the charts and share them. So this is an example of like a sophisticated Shiny app. I'm curious. Yeah, you can even download the data um and do stuff like that. So something like this would be really useful for people like working in the like trade policy, let's say, in the New Zealand government. Okay, so let me go back to my presentation. And this is all written in R. Okay, so what does a Shiny app look like? So basically, Shiny apps have two components. So first of all, the Shiny library is what they depend on. That has all the code. And then they have oh, by the way, I totally forgot to mention the reading assignment. There's like a book by Hadley Wickham on Shiny apps, and the reading assignment, it's kind of similar to the R for Data Science book that he wrote. So it's like kind of short chapters. So the reading assignment is like the first 4 chapters. But really, if you do the first 3, it would be great. Um, so basically, there's a user interface, and that like contains the code which controls what the person sees and how they interact with the web page. So that is defined by a variable, and it's like usually triggered by a function. So there'll be different types of functions for different types of page layouts, and then within the function you'll have like more functions to kind of lay out all the different elements. This is a super simple Shiny app that doesn't do anything. It just prints hello world. And then there's a server, and the server is where the calculations happen. um, and basically the server has 3 variables. So input, the inputs are variables that are going to be determined by the user. So the user is gonna like mess with some sliders, like enter some numbers, type stuff in, click on options, and that's gonna set the input variable, and the input variables can't be changed, and then the output is going to be calculated by in the server in some code, and that's going to get sent back. That's going to be communicated backwards to the user interface and put into the charts and stuff like that. So these input and output variables will contain um, will contain like a list of variables each, and then sessions we'll get to it um, maybe next week, but it's not always needed. Okay, so let's look at the Old Faithful example in detail, and maybe so here's the user interface. Um, and maybe actually I'm going to do this in our studio. Let's see which is which. Yeah. Okay, so let me. Okay, so here I have the code which defines a Shiny app. And this is doing the Old Faithful example. And so here I have my user interface variable, and it's going to be equal to a function. So the function is fluid page, and that's just a certain style of page. And then the arguments to that function are just the different, like, they're going to be like the different elements of the page. And so in particular, I'm going to have a title panel. That's going to be my first argument. So if you look at it closely, you can see there's a comma here, and so we can see that appears up there. I kind of want to run. This isn't showing the sidebar. Let me see. Okay. Yeah, so this makes it look, you can see the sidebar actually on the side here. So yeah, there's the next argument is this like sidebar layout. And you'll learn about this stuff as you go, which specifies that we're going to have a sidebar, and then the sidebar panel just puts an element in the sidebar. And then I have this thing called slider input. And there are going to be these functions, and they're all going to have input, and they're basically going to create the different types of inputs. So here, slider input is exactly what it says. It's an input where you slide, where you move a slider to change the value of something. And in this case, it's the number of bins of the histogram. So as I just scroll this, it changes the number of bins of the histogram. And then there's going to be a main panel, and in the main panel, I'm going to call, and so this is another argument these are all arguments to the fluid page function. And the main panel, so this is another type of visual element. And then I'm going to put something in the main panel. So just like I had slider input in the sidebar panel, which was a slider, in the main panel, I'm going to put a plot. And it's going to plot, so plot output basically is going to look in the output variable for something called the dist plot, and it's going to plot it. So that's how the user interface is working. Let me see. Okay. Yeah, and that's kind of what this page says. Okay, so now let's look at the server. Yeah, so here's the code for the server. So I have the input and the output, and I am going to calculate the out. So I want the output to have a plot called dist plot, because that's what I want to show. I want to show a plot of the histogram of eruption times. And so I'm going to create that with a function called render plot. And basically, like within Shiny, there's like a ton of different functions that all start with the word render. And those are functions which basically basically create like an object that you can put into the output. So I'm going to say like the output's going to have a component called dist plot, and I'm going to set it equal to the outcome of this function. And then here I just generate my graph using ggplot. And so the faithful data set's built in R, so I can access anything in R, so it's easy to access it. Normally you would have to have the data set like accessible somewhere else and you load it in. But yeah, I just do my regular ggplot code, but the key part to notice is here in geom histogram, I'm using the input value. So this is what is set by the slider. So whenever I change input, whenever I move the slider around, so if I move from 24 to like 36, that changes sorry, too many screens. That changes this like parameter in the plot code, and it triggers it to recalculate the plot with a different number of bins. And yeah, so there's various other rendering functions. So render table will create like a table of data. Render image will make an image. There's like render text, which will write a little message. And so there's a variety of these. And you can see a list of all of them by looking at the documentation for Shiny. And similarly, like there's a ton of different inputs. So let's take a look. Let's actually take a look a little bit closer at the slider input command just to see what's inside it. So basically, the first uh, the first element of the slider input is the name of the variable that's going to be changed. And then the second, or the first of this input function, the second is going to be like a label describing, so that this is going to be what the user sees, so they know what they're doing. The value, this is a default value. So if they don't touch it, like, and are doing other stuff, this is the value it will take. And then there's like a min and a max, which set the limits of the argument. So basically, like for these input functions, typically the input ID is the first argument, and then the label is the second argument, and then you have a bunch of other arguments that just depend on the function. And there's like functions for inputting text, numbers, dates, categories, like anything you could imagine. Um, so for example, this is sort of funny. Yeah, so here's three examples of the text of text inputs. So the first one is for a name, and so in the input variable, I'd be able to like type into this box. Sorry. So my password manager like decided this was password. But I could like type something, some random text, or I could just type George, whatever. And this like turns the name variable into the character George, and I could type a password in. I could like give it a self description, like I check CUNY. And then all of these inputs would go into the described variables. And you can see here that I have if I type in the password, it's like obscure. So you could even have like even protect you could even protect your Shiny app if you didn't want everyone to be able to use it. And yeah, okay. And then for numeric input, there's a variety of ways of doing it. I could just like type a number, so just a standard numeric input, and I can have a min and a max. I can have the slider, as we already discussed. It goes between 0 and 100. And then you could even have a range, and this range will give you two values. So I could have from like 10 to 76. So I could set a range for a figure like this. And so that's I believe that's the case. Uh, yeah, I'm just trying to think. Yeah. Yeah, so I think yeah, so I'm kind of curious to test it, but I believe you could also have an input of like as many numbers as you wanted if you had the default value being several here. So So, yeah, so that's some different ways that numeric inputs work. Okay, so let's talk about the outputs. So um, the output variables, as I said, they contain data that was generated by the server. So it's kind of the output is kind of like a list. And there's various different ways of accessing the output values in the user interface in order to display them. And typically, like you do it with functions that have the word output in them. So plot output, that like uh, typically you'd want your plot. So this is like this is going to look in the output variable for an element called plot, and that better be like a plot. And if it's a plot, then it's going to graph it for you. And then text output, that's going to look in the output. This could, for a variable called text. So I could change these names here. It doesn't have to be like a super descriptive name. And then then it would display the text. And then verbatim text output, it's like another text output. But basically, like there's also a table output. Etc. So there's a variety of different output functions. All right. Sorry for my password manager. Yeah, so then outputs are, generally speaking, they're created in the user interface, and they're always created, or they're almost always created with a function um, called render that starts with a render. Um, And so here's an example I showed earlier. So we're setting the plot of we're setting our histogram plot, and we're going to set it using this render plot function. And then the code inside is going to has to generate a plot. Otherwise, this would be wrong. And so if the code has multiple lines, or if it's you have to enclose it in braces. But you can basically like just write code in here that calculates something, and it'll use the last output to send into here. So if I wanted this to be a number, I think I would do like I think it's render. I can't remember if it's render number or render numeric, but yeah, like you could have a bunch of code, and then the last output would be what's stored. Okay, so now I'm going to start to get to a little bit of the slightly more complicated features. So how do we access the inputs? So suppose that I tried to do the following in my user interface. Suppose I tried to plot. So suppose I just had like this code in my server function where I tried to create a plot variable, and then I tried to set it equal to something. And here you can see I'm using the input um, in my geom histogram. So taking the input, and then I'm going to render that using render plot to send it to the output. If I do the code this way, it's going to produce an error. Um, and the reason is that the in order for Shiny to work, it has to be extremely careful about it has to like you have to structure your code in a way that Shiny can figure out the dependencies of like every output variable on the input variables. And so typically if you're going to access an input variable, it has to happen in a special part of the in a special type of environment within the Shiny function. And that's called a reactive environment. Um, so if I had code here and I just set the bins equal to a number, then I could pass it into render plot, and it would be fine. And I could actually add like within render plot, I could add, if I could add like another feature that um that like involved the inputs, and that would work. But if you try to access the inputs outside of what I'm going to show in a minute, which is a reactive environment, you'll get an error. Okay, and so now I'm going to talk about this idea of reactive programming. So the basically the secret sauce of Shiny is that it involves something called reactive programming. And so like why can't you just like why can't Shiny work like a regular program? So the problem Shiny has to solve is like, how do you decide how to update the display when a user changes a variable? So let's say they change something on the display, and like in this hypothetical example, like I go from here to here. Yeah, how do I decide? How does it decide what to do? So one possibility would be to just calculate the entire website all over again from scratch. Um, and this is very inefficient. So in the case of the Old Faithful example, it's not like it's exactly what's happening, but it's like that's a really simple example. If you had some kind of fancy model in the background, and then you wanted to change the color on your graph, and it just like recalculated the entire fancy model, that would be stupid. You wouldn't want to do that. Or if you had a page which has like 20 different figures and they're all hidden in different places, and you like make one small change, and then you had to recalculate the entire page, that would also be really inefficient. Um, so another way that you could try to do this is with a programming paradigm called event-driven programming. And this was maybe common like about a decade ago. So you'd have these functions that are like waiting for an event to arrive, and then when an event arrives, they like try to figure out you code up what to do like when the event arrives. But you basically have to like kind of hand code that in. So you would have to like have a function which said, "Oh, if slider input changes, then like update the graph." And that is fine, but when you start getting a complicated website, it can be difficult to manage in your head, like all the dependencies of different graphs on the different inputs. And so what reactive programming is kind of like a simpler way to handle that event-driven framework. It's a way to do the event-driven framework like automatically. Is one way to think about it. And so basically, what does Shiny do? So Shiny has within it special types of variables called reactive expressions. And each reactive expression like depends on other reactive expressions, and also is dependent on wait. So basically like each reactive expression like has some dependency. So there's some expressions which depend on it. And then it also there's also some dependencies which anyways, you get the point. Like there's a variable, it feeds into some other variables, and then there's variables that feed into it. And the variables that go into this graph are called reactive expressions, and they're treated very specially by Shiny. And basically like the inputs and the outputs are are like are special cases of these reactive expressions. And so the basic idea is that when an element in the reactive expression changes, when one of the inputs change, Shiny can figure out like everything that depended on it by just tracing through the graph, and then it can know exactly what it needs to update. And so here's like a picture of what that might look like. So here's like a diagram. Let's say you had an app with 3 inputs and 3 outputs. And here you have some intermediate variables that you're calculating, and then they feed into the 3 outputs in according to this structure. And so this basically lets Shiny figure out what to do when you make a change. So if you were to change this variable, what would happen is it would see like, oh, this one is the next in the graph, so I'm going to change it. And then it's going to change this one. But crucially, it's not going to do anything with this or the dependencies. It's just going to use that variable, which is already set. So it's going to use it's going to use this already saved variable and this changed one, and it's going to recalculate, and then it's going to recalculate these two. And similarly, like if this one changed, the path would go, okay, so this one changes this one and then changes this one, and you would only do this like minimal set of computations. And so every Shiny app in the background has built like one of these graphs, and that determine how the computations happen. So, okay. Yeah, so talking about the server a little bit, yeah, I suddenly feel like this slide is a little out of place. But yeah, basically like a Shiny, so like uh every time someone visits your Shiny app, it creates like a new server instance that's running. So it's not like there's one server um that is like running in the background and that's interacting with all the users of your website. It's basically like each person that visits gets their own like process that is dedicated to them. So it's not as if like I change the slider on my webs on my browser and then it like changes what someone else is seeing it. So it so we so this is maybe if you're like more into web programming, just to understand what the server is doing. Um, okay. And all right, so yeah, so let's talk about some of these reactive entities. So input is like the first reactive expression, and it's basically it's basically a list of variables that are created by the user. And the important thing about the input is that inputs can never be changed except by the user. So the only way to modify, if you try to like modify the inputs in your code, it just won't work. You just won't be able to do it. Um, so basically they can only be modified by the app user into user interface. Um, so if I like do this where I create a count and then so I create like a numeric input. So if someone types in the count, um, the number of variables they want. If I then try to change it later in the server, I'll get this error because yeah, it's just not allowed to be changed. And so to access the input, you have to be working inside a reactive context. That's the rule of Shiny. And there's basically two reactive contexts that you can use to access the input. One of them is going to be a word that's called reactive. Um, and so there'll be functions that start with reactive, and then there's another one that's functions that start with render. And so the render functions will do stuff to the output, and then the reactive functions will create like intermediate products. And basically like Shiny in the background is gonna keep track of like all the reactives that you create and all the renders and all the inputs. And that'll let it create a parsimonious graph. Okay, so similarly like outputs, also a list. Yeah, I feel like it's just like the mirror image of input, except you can change it. Um, but basically, yeah, you're never allowed to read the outputs out or write them outside a render. Yeah, so as an example, if you're not allowed to do this, you can't like, set the, add a variable to output like outside of some sort of render environment. So I'd have to use, I believe, render text. I'd have to say like output greeting equals like render text, hello human. Okay, so let's like look again at this idea of reactive graph. So here I have a really simple app. Actually, should I show it? Yeah, maybe it's easier to see if we show it. Which one is it? Yes, this one. Let's see, does it work here? Yeah. Okay, so here's an app where I type my name in and then it tells me hello. And so basically like if I type G, it says hello G, and then like as I'm adding letters, like it's basically It's basically adding to my name. So it's a really simple Shiny app. So here the user interface, it has one text input, and it's my name, and it's labeled with what's your name. So that's what you see here. And then it has one text output, which is the greeting that it's going to give to me. And then in the server, I set the greeting, but I set it by using a reactive environment. So I use render text, and I'm basically just pasting together hello with um, my name. So taken from the input and then an exclamation point. All right, so this is a very simple app, but you can basically like just, I guess I've said it, but you can get the idea of how name and greeting are connected. So um, we basically see here that um, output greeting, it is set by this render text. And so then Shiny will see like, oh, input name appears in this render text, and that's a reactive variable. And so now I know to draw an arrow from input name to output greeting. And so you get like something like this. You get like a really simple graph where name goes into greeting. And then you could like build a more complicated expression. So this does exactly the same thing. So let's say I wanted to add the I wanted to create that message before putting in an output because I want to use it for something else, for some other part of my code. So I could do that. So I could create a new variable called string. But if I wanted this to be a reactive variable that depends on the input, I have to put it in this reactive environment. So if I put the reactive function and then I put my code inside, it will create a new variable, and I will get this set of dependencies in the code. So I'll get like name feeds into string, feeds into greeting. Okay. And so crucially, the way that a Shiny app is run is definitely not in the order in which you see the code appear in the script. So it's not an imperative program. So normally when you program, like you write a bunch of instructions in order, and then then like R or whatever just goes through those instructions in order. It's not the case with reactive programming. Um, Basically the code is executed only in the order that's specified by the graph and how the inputs changed. And so what that means is I could actually write, wait, hold on. Do I have, I'll just show you. So let me see. Yeah, so this was the example that I had before, but except with the order, I see the problem is I needed a gap there. Um, is basically with the order reversed. So here, like I'm creating the output first, right? I'm saying, okay, the output greeting is equal to render text of string, but I haven't made render text. I haven't made the string variable yet. By the way, notice that when I call a reactive variable, I need to put these braces next to it, or these parentheses next to it. So if this was an imperative program, this wouldn't run because here I haven't created string yet. And so it wouldn't know what to do. But because it's not, basically like Shiny figures out that you can't execute this code until we have a value for string. And so only when basically the string code is triggered does the code above it get triggered. So that's a helpful feature to be aware of. So that can kind of make this programming like a little bit counterintuitive. So just, yeah, so that's why I'm going through it. Okay, so yeah, so basically like you could think of each reactive variable as being either like a producer or a consumer of other reactive variables. And basically the inputs are only producers. So they only like send data to other expressions. Then there's expressions which can do both, so they both receive input and then feed into other expressions. And then finally the outputs, those can't be used by anything. They can only be displayed. So um I had hoped, I'm like running a little bit late. I think I'm going to go through this example in the next lecture because it's like a little bit more involved and shows like why this reactive stuff is useful, but I don't want to rush through it. But basically, yeah, I think this will take me like 15 or 20 minutes, and so I don't want to go. So I'm gonna end this lecture here, or this meetup here, and pick up pick up here. I'll either pick up next time or maybe I'll make a separate video and where I just go through this later and you guys can watch that. Um, but yeah. So I'm gonna stop now, and are there any questions?
Yeah, so I have a question regarding that. When we are starting the code for Shiny app, it's in the same Corto file or in
So
R or
um
something else.
I would recommend that you don't make a quarto for your homework at least. So normally I'll show you how to do it. So normally what you do is you go to so within our studio,
Mm-hmm.
so firstly you can always create a directory and then make a file called app.r. And then as long as it has you know the as long as it has this name, our studio will recognize it as an app. And then if you give it the ingredients of a Shiny app, um, everything will work fine. But you can also just do something like this. If you want to start a project, you can go file
Are you
new Shiny
sharing?
web app.
Sorry.
Oh, I'm not
Is it
sharing my screen. I'm sorry, I
No,
forgot about that.
no, that will be great if you share.
My bad. Hold on one sec.
No, you're good. Thank you.
That's my bad. Sorry. Um, let's see. Okay. Yeah, so yeah, so first of all, you can just make a file called app.r. That's the simplest way, or that's a simple way. For more complicated Shiny apps, couple files can be involved. But oftentimes it can be self-contained within a single file. But you can also have our studio create it for you. So you can go to file, new file, Shiny web app, and like do my app. And so you can see there's like two different options for how you do it. And so then it'll create this like default. This is actually the old faithful example, but I think a lousier version because it doesn't do tidyverse. Um but the point is, like, generally speaking, you want to make the app like this. You can theoretically do it within a Quarto document, but for your homework, I recommend you don't do that. I recommend that you create like kind of one Shiny app for whatever it is you would like to do. I'll show you what it looks like, and so you can look at my slides to see how it works in Quarto, just in case, because it's a useful thing to be able to do. So let me see where I do it. Yeah, so you do it like this. Um, yeah, so well here I don't want the server to do anything. So, but this is kind of how Shiny looks like in the in a Quarto document. So it's a little bit different. So you have like yeah, so you have your different like inputs here, and you could put different panels as well. You could like call this a panel using like in kind of the same way as this. And so you could kind of make a layout on the Quarto page, but I don't think it will look great. I think you will be limited if you try to make your app in Quarto, or I
Yeah,
think you'll do better just making it standalone.
sure. Thank you.
No problem. And I was gonna say something, but I forgot.
Professor,
Mhm.
while you're thinking, one thing I noticed, so from what you're showing and comparing it to how we've been doing our assignments, and as slide presentations is so on the slides we can have a little blurb to guide the story, but in the Shiny apps, from what I'm seeing, you don't have that. So
Yeah.
is there some way to include that, or do you not include anything and let people make their own interpretations?
So you can have you can include text. I guess like I haven't included too much text in these, but generally speaking, so this is a tricky part. So um it's so so depending on, it's like kind of harder to tell a story with a dashboard. Um the way to do it is to like, is to kind of allow for the person to view the data, like it's kind of to set the context basically with the types of visualizations. That's, I don't know, I'm not describe this is something I'm going to talk about next week a little bit
Okay.
more, but like it is definitely it's definitely not the same. It's not the same like where you're doing a slideshow where things are flowing, or but you can still like incorporate some of those aspects. And I would say there's different purposes for dashboards. So sometimes people just want a dashboard to like, yeah, to look and see what's going on. And but even in that case, like the way you design it can like convey some kind of story. Like for example, I had um like I'm not sure if anyone really used it, but I had a colleague who made a Shiny app like which predicted, we took COVID data and it was sort of like estimated, it like had a model in the back. I bet I can find it. Like it um so it's like Joshua White's, I think it like estimated yeah, this is maybe kind of a bit silly, but I think this is like a really good example of maybe doing a better job. So can you see this?
Yes.
So like so basically like so basically like there's no more data anymore. Yeah, so it's not gonna show it. I totally forgot about that. Um but basically like this would be showing like the percentage chance of someone having COVID at your event based on like their mathematical model of like all the data. And you could like look at this risk level and decide like, based on your personal situation, like whether you should like have the event or not. um uh and then but then it kind of has this like information. Sorry, this website's kind of deprecated, but it has like some information on the right. um and yeah, but anyways, there's ways you can make them better, but it's more difficult for sure. And so because it's more difficult, the expectation is different, um basically is what I would say. so
Okay.
so I don't expect like a full as much of a narrative, but if you can't, like if your data story, if you have a narrative and you can still like, and you can still like structure, you can still have that narrative like be there, but the person can see like more context, um or they can discover the narrative through the way that you arrange stuff. Like that would be the best way to do things. I
Okay. Thank you.
completely lost where my Zoom screen is, but oh, it's because I'm screen sharing. Yeah, anyways, I've been thinking about like how to handle that, how to handle like this difference between dashboards and other visualizations, but we'll talk about it next week. Okay, are there any other questions?
Uh, just like some house stuff. Just um, I know I'm speaking for myself, but some of my work was handed in late. I'm wondering when we can expect feedback on some of that stuff.
As soon as I possibly can, I'm working on it. Like I'm gonna
Thank you.
try to. I would love to get caught up by the end of this week. We'll see. But I know I should get it in sooner. Yeah.
Yeah. I know it's not super obvious, but in a lot of my presentations, because I went with the slides presentations, I got slide notes in, and I didn't make a note of that until later on. So, like a couple of the assignments, if you have to like view it in presenter mode to like see what
Okay.
the talking points would be.
I'll keep that in mind.
All right, cool. Thanks, man. Have a good one.
You too.
Thank you. Good night.
Yeah. Have a good night, everybody. Talk to you guys later.
Thank you. Bye.
Bye.